All right, so we're going to go ahead and create our magnitude and phase plots like we said we were going to do, and we're going to use the two functions that we have in terms of f. I think that that's probably the best way to do this because the functions in terms of f are the ones that we're typically going to be looking at. It's okay to do the math in terms of omega just to keep everything clean and keep all the 2 pi's out of there. But typically we're going to be interested in things that are in terms of the frequency in hertz rather than in the in terms of the angular frequency, okay? So let's go ahead and let's throw our magnitude plot over here on the left, and we'll throw our phase plot over here on the right. Okay, so I'll go ahead and sketch some axes here. And I've already taken it upon myself to throw the values into my calculator so that we don't have to sit here while I do all that, plugging into my calculator and so on. And so I guess that for the magnitude plot, this makes sense, but I'm going to probably have to move this guy for the phase plot for it to make sense. Okay, so that's going to be what I do for my magnitude plot and my phase plot. Let's just write again that this is the magnitude plot. This is the phase plot. And again, this is for an RC circuit. I picked values here for R to be 1 kiloohm and C to be 1 microfarad so that we could get some real numbers in here. Okay, so I'm basically looking at an RC circuit that's got an R value of 1K and a C value of 1 microfarad, okay? And we're looking at the ratio of V out to V in here, okay? And so let's go ahead and see what I came across. So I plotted 6 different frequencies. I did 1 hertz, 10 hertz, 100 hertz. Let's go 1, 10, 100. Put 1,000 here and 10,000 here. This is all frequency in hertz. And then I also plotted 300, which would be like right around here somewhere. Okay. And then I have the same. I basically will do the same exact thing, but for phase. Let's see if I can grab all those. I guess I missed out on the 300 tick mark, but that's okay. All right, so those are going to be my 2 plots. Here I'm plotting magnitude, of course. Here I'm plotting phase. And so for the magnitude, at a frequency of 1 hertz, I got a magnitude of, a magnitude of 1. I'm basically going between 1 and 0 here. I'll go 0.5, 0.75. And so what does this mean? What does it mean that at a frequency of 1, I get a magnitude of 1? Well, what I'm looking at is the magnitude, again, of the ratio of the output voltage to the input voltage, right? So if the ratio is 1, that means that the output voltage is equal to the input voltage in magnitude. So if I go back to this plot here, right? This signal here is equal to this signal here, right, in magnitude. They're the exact same magnitude or the same amplitude sine wave. So in this case, a value of 1 on the y-axis basically corresponds to my output signal and my input signal being the same in terms of magnitude, right? And so that's what I have at a frequency of 1 hertz. What do I have at a frequency of 10 hertz? At 10 hertz, I have 0.998. Okay, so I'm starting to decrease, but very slightly. I'm just barely below 1, right? And that's basically saying that my output is 0.998 times my input, right? So basically, my output is still very similar to my input in terms of magnitude. What happens if we go to 100? Well, if we go to 100, it says that my magnitude is 0.847. So that would be right around here somewhere. What about at 300? Again, this is me. I just basically set this function up in my calculator, and I just plugged in these values for f, and I'm plotting on the y-axis what values it spit out, right? So I plug in f. I already plugged R and C into my calculator as 1 kiloohm and 1 microfarad. And so the f values that I'm plugging in are what I have here on the x-axis. And then I'm just plotting for you what I got out on the y-axis so that we can see what this magnitude plot looks like. So at 300 hertz, I get 0.4686, which would be right somewhere right below 0.5, so right around here maybe. Maybe I drew that a little bit low, maybe right there. And then at 1,000 or 1 kilohertz, I get 0.1572, which would be down here somewhere. Right around there. So that would be right here. And then at a value of 10,000 or 10 kilohertz, I get 0.0159, which is really tiny, pretty close to zero right there. And so if I go ahead now and connect the dots, this is my magnitude plot for this circuit. Okay, so that is telling me that this is what would happen to the magnitude of the ratio, right? I'm taking the ratio of my output voltage to my input voltage as I vary the input frequency in this circuit, right? I'm looking at this circuit here this whole time. I'm taking this sinusoid and I'm changing the frequency at very, very, very low frequencies. I get a value of 1 for this ratio, which basically means my output and my input are roughly equal to each other, or exactly equal to each other for some small range of frequencies. As I increase the frequency here, right? As I increase the frequency, my magnitude starts to drop. My magnitude of my output drops. Of course, my input is fixed. So if my input is fixed and my output is dropping, then this ratio is dropping, and that's why we're seeing the transfer function start to drop. And so as we move into this range between 100 hertz and a kilohertz, I get this super steep drop off where my magnitude of the output really starts to decrease. And then eventually it just tapers off to 0, to where I basically have an output voltage of 0. So my ratio here of my output voltage to my input voltage goes to 0. And so this is the magnitude plot for this particular circuit. This is what the frequency response is. So now if I wanted to know, now that I've drawn this curve, if I wanted to know the magnitude of the output with respect to the input at any frequency on this curve. So if I wanted to know it at 50 hertz, or I want to know it at 700 hertz, or I want to know it at 6 kilohertz, I can figure that out just by going and figuring out where it falls on this curve, right? And so this is a very powerful tool. Okay, so real quickly, let's actually let me go ahead and end this video since I've been talking about the magnitude a lot. I haven't talked about the phase a whole lot. So I'll end this video here since we drew the magnitude plot. And in the next video, I'll go ahead and sketch the phase, and we'll talk about that one as well, because these two plots are very heavily linked, as you know, from this figure. There's not just a shift in the magnitude, there's also a shift in the phase. So we need to take both of those things into account, okay? As we vary the frequency, okay? So we took care of the magnitude. In the next video, we'll take care of the phase plot.